Now student, we are going to discuss this question number 6.11, and in this question it is given to you, suppose the loop in exercise 6.4 is stationary. Clear? So in exercise 6.4 it is given to you, let's suppose I am assuming this is magnetic field perpendicular inward direction. Clear? Magnetic field, this is perpendicular inward direction. Clear? Let's suppose I am taking here a loop. Let's suppose this is loop. Clear? And actually it is given here this loop is in cut. Clear? But it is also given here in exercise number 6.4 that this value of this length. Clear? This length is given to you 8 centimeter. Clear? And this value is also given to you, this one is 2 centimeter. Clear? Now let us try to understand this question. Now it is given that this loop is stationary. Clear? The loop is given, this is stationary. Okay, I can say this is stationary. But the current feeding the electromagnet that produces magnetic field gradually reduced. It means what I am saying to you. Actually, definitely we place here this loop, and definitely here we have a magnetic field. But that magnetic field comes from where? Actually that is magnetic field is produced by a electromagnet, and in electromagnet we produce magnetic field due to current. But in this question it is given to you the current feeding electromagnet is now reducing, and so that we can say the value of this B is decreasing from initial value. Initial value is given Bi, this is 0.3 Tesla. This is initial value at the rate of 0.02 Tesla per second. It means I can say value of dB by dt we have 0.02. This is Tesla per second. Clear? Now it is given if the cut is joined and the loop has a resistance of 1.6 ohm. 1.6 ohm. Now our objective here is to find power dissipated by loop. Clear? So very simple question we have. Clear? Now what we can do here? First of all, we can write like this: induced EMF in magnitude, this is given by d phi by dt. Clear? Phi we can say that is equal to what? BA. Clear? And from here you can also write like this is A dB by dt. Clear? So from here we can say this is average induced EMF. This is given by area. Area we have 8 into 2 into 10 to the power minus 4 multiply dB by dt. Clear? dB by dt is given, this is 2 by 100. Clear? So from here we can write like this: 2 multiply to 4, and 4 we can say 32 into 10 to the power minus 6 volt. Clear? So 8 multiply 4, 32 multiply 10 to the power minus 6 volt. Clear to everyone? Now my here next objective, because this is loop, I can say induced current. Induced current is given by E by R. Clear? Value of R is given to you, this is 1.6 ohm. So I can say 32 divided by 1.6 into 10 to the power minus 6 ampere. Clear? From here we can say if we remove this decimal, clear, here we become 10 to the power minus 5, and directly you can say 2 into 10 to the power minus 5 ampere current we are getting. Clear? 2 into 10 to the power minus 5 ampere. Clear? Yes. But what is our objective? Our objective here is to calculate power, how much power is dissipated. Clear? So power dissipated, how can we find power dissipation? Power dissipated. Clear? So we can find power. This is given by I square R. Clear? Value of I we have 2 into 10 to the power minus 5 multiply 2 into 10 to the power minus 5 multiply value of R, this is 16. Clear? I mean 1.6. Clear? So from here you can say this is 4 into 10 to the power minus 10 multiply 16 divided by 10. Clear? So I can say this is 64 into 10 to the power minus 11, and I can say this is watt. Clear? So I can say this much amount of power is dissipated. Now you can say, so, from where we are getting this power, or from where we are getting this power is dissipated. So actually now you can say in this question actually we are reducing current. It means whenever we are reducing current, it means we are reducing from some external source. So we are getting that energy from an external source. Clear? So this is all about this question.